Now, so far in this module, all the quadratic functions that we've looked at have fit the general form that you see highlighted in red, which is the y equals a times x minus h quantity squared plus k form. And in this form, we can easily pick out the coordinates for the vertex and also the equation for the axis of symmetry. But what happens, though, if we're given an equation in the form like what you see at the top here in blue, which is y equals x squared plus 2x minus 8? How do we find the vertex and the axis of symmetry for that kind of equation? Well, all we have to do really is to take that equation and put it back into the other form by the process of completing the square. So let's see how that would look in this case. Now, to complete the square, you know that we only need to use the x squared in the x term. So what I'm going to do is to put a blank after the 2x term here in this case to represent the constant that we're going to have to add to complete the square. Now, I think you can see that half the coefficient of x, which is 2, is 1, and if we square that, we add 1 to complete the square. Now, what we've done is to add 1 to the right-hand side of the equation, so what we need to do to balance the equation then is to subtract a 1. So now if we factor, we're going to have y is equal to x plus 1, quantity squared, then minus 9. So now we have the equation in the other form where we can pick out the vertex and the axis of symmetry. So the vertex, I think you'll agree with me, we'll have the coordinates -1, -9, and the equation for the axis of symmetry will be, I know you're ahead of me here, so the equation for the axis of symmetry then will be x is equal to -1. Now we also know that the parabola will open up because the coefficient of the squared quantity is +1. So next we'll find the intercepts and then sketch the graph. Now I have stated at the top here the new form for the equation that we found by completing the square, which is the y equals x plus 1 quantity squared minus 9. And we determined the vertex to be -1, -9, and the axis of symmetry to be x equals -1. Now our next task will be to find the intercepts for the graph, and in this case it'll be much easier to go back to the original equation to do so, and that will be the y equals x squared plus 2x minus 8 form. So to find the y-intercept, I know that you remember that we're going to replace x with 0, so we have then 0 squared plus 2 times 0 minus 8, which simplifies to -8. So then we can say that the y-intercept will have the coordinates 0, -8. And to find the x-intercepts, we'll replace y with 0. So we have 0 then being equal to x squared plus 2x minus 8. We can factor that, in this case, into x plus 4 times x minus 2. And so this will produce the x values of -4 or +2. So we can then say that the x-intercepts will be the points -4, 0, and 2, 0. So next we'll put all this information together and sketch the graph. Now you can see that the graph of the function is sketched below here in red. Now what I did first was to plot the vertex, which is -1, -9, which I'm going to highlight in green down here at the bottom of the parabola. Then I plotted the y-intercept of 0, -8, which I'll highlight in green next, which is right on the y-axis. And then the x-intercepts of -4, 0, so that first one will be up here to the left of the axis of symmetry, and the x-intercept of 2, 0 will be up here, again highlighted in green, to the right of the axis of symmetry. And what I did finally before I sketched the graph was to go down and find the partner, if you will, to the y-intercept to the left of the axis of symmetry. which I'm going to highlight now in green. Then what I did was to take and draw a smooth continuous curve through those 5 points, and we have the graph.